Hi friends, it's Ms. Deering here today with our first math video. If you have your math book from school, we're going to be talking about things on page 109 to 118. If you don't have your math book, that's okay, just follow along. What we're talking about today is coordinate grids and how we can use ordered pairs to name points on a coordinate grid. You already know how to do this from marking how you feel on the mood meter. We also use coordinate grids when we find a place on a map. You even use coordinate grids when you play Battleship with your cat. So what is a coordinate grid? Well, we've used them before with the mood meter, and we've used all 4 quadrants. Today we'll just look at positive and positive as if we were staying in the yellow. A coordinate grid is as if we had a number line going horizontal along with a number line going vertically. And using those two together, we can plot exactly where something is along a flat plane. Here we have our x-axis in green and our y-axis in blue. I have a little way that I like to remember them. I write my x all squishy so that it goes this way, and I write my y all long so that I can remember that x is this way and y is this way. There's a special way that we say where things are on a graph or on a coordinate grid, and it's called an ordered pair. That's because we put a pair of numbers down in order. For example, we can say where the yellow smiley face is by saying that we go 1, 2, 3, 4 over on our x-axis, and 1, 2, 3, 4, 5, 6 up on our y-axis, and write those down as 4 on the x and 6 on the y. We put them in parentheses, and that's called an ordered pair. And you can use this like an address to find exactly where you want to go on your coordinate grid. We have to put these numbers in the ordered pair in the correct order. We have to do the x before the y. So we put 4 and then 6. Remember this handy rhyme: X before Y, run before fly. Here's Hedwig. Hedwig has to run along before she can fly up to the 6. Let's practice this. So let's find out if we can say exactly where the red smiley face is. If we go along the x-axis, 1, 2, 3, and then up the y, 1, 2, 3, 4, 5, we find out that the red smiley face is at 3, 5, and that's its address on the coordinate grid. Let's look at the opposite. If we go 1, 2, 3, 4, 5 and put the 5 first and up 1, 2, 3, that's a completely different place. So it really does matter which order you put your ordered pairs. That's why they're called ordered pairs, because the order matters. Let's look at this yellow smiley face. It is 1, 2, 3, 4, 5 along the x, but it is 0 up the y. Here's Purple Batman Guy. He wants to get to that purple star. Can he climb up the y-axis and then get over to that purple star? No, he cannot. He needs to carry his ladder along the x-axis, then he can climb up the y-axis to find out where the purple star is. So we find out that going along the x-axis to the 8, we're right under the purple star, and we write 8 before we write how far we go on the y. And how far up do we go? We go up 7 along the y-axis. So the ordered pair for the location of the purple star is 8, 7. And that means 8 along the x and 7 up the y. Let's recap all the things that we've talked about. When we name an ordered pair on a coordinate grid, we put the x before the y coordinate. X before Y, run before fly. Remember that Hedwig had to run along before she could fly up. So when we make an ordered pair, we put the X coordinate here and then the Y. The x-axis is the horizontal one, and the y-axis is the vertical. And I had that sneaky trick to remember by making that y really long. I have here a graph that shows money up the y-axis and time across on the x-axis. I'm going to talk about how we use points on a coordinate grid to tell us some information or make some predictions or show what has happened. Look how long my grass is getting. I think I need my neighbor Oscar to come and mow my lawn. Let's make a prediction. If I pay my neighbor Oscar $5 each month to come and cut my grass, how much money can Oscar make by the end of the summer? Well, we see he made $5 in April. If I give him $5 more in May, he will have made 10. In June, if I give him $5 more, he will have made 15. But how much will he have made by August? 2 more months go by, and he gets 2 more $5 bills. We can predict that in August, he will have made $25 cutting my grass. So let's see if our prediction comes true. $5, $10, $15, $20, $25. So by drawing a line through the points, we can predict how much money Oscar will make this summer cutting my grass. Here's what it might look like if Oscar's family left town in June and he didn't cut my grass. If he made $5 in April and $10 in May, but in June they left and he still had that $10 bill in his pocket. And they came back in July and he still had that $10 bill in his pocket. Then in August I paid him $5 more. Then he had $15. Let's see what that would look like. He made $10, then it stayed even, and then he made $5 more. So you can use a graph to show a picture of what happened in time. Why is time usually along the x-axis when we make a graph? It's because time marches on. Unless you have a handy time machine, time will travel pretty much in a linear way. You'll have April, May, June, July, August, September, October, and on and on. So you put the thing that doesn't change along the x, and then you put the thing that you're measuring, the thing that can change, along the y-axis. In this case, we have money, because I could give Oscar $5, $10, $15, $20, but what if he leaves town and my grass grows? Then he might not get the $25th dollar. Thanks for watching, and I wish we could all climb into a time machine and get back to school together.